All right, let's dive right in.
Sounds good.
Today it's all about C++ standard template library containers.
Ah, yes, STL container.
You know those STL containers, the ones
No.
everyone's always talking about.
Yeah, they're pretty powerful.
You sent over C++ STL.pdf, which looks like a pretty thorough guide on these
It
tools.
covers quite a bit, yeah.
I'm excited to see how they can take C++ coding to the next level.
Absolutely.
Efficient data handling is key in any program.
It really is.
The heart and soul of good code, right?
Oh, for sure. And the C++ STL is like having this master craftsman's toolkit right at your fingertips.
Well, I like that analogy.
Yeah.
A master craftsman's toolkit.
Exactly.
Pre-built components, specifically designed for managing data.
Saves you from writing everything from scratch.
And potentially making costly mistakes.
Oh, yeah, for sure. Mistakes that could really slow things down.
Okay, so a master craftsman's toolkit.
Precisely.
The document seems to split these containers into two main groups.
Oh.
Sequence containers and associative containers.
Right.
Let's start with that first group.
Right.
The sequence containers.
Sounds good.
What exactly makes them sequential?
Well, think of sequence containers as organizing data in a straight line.
Oh.
One element after another.
Right.
Just like a to-do list.
Uh-huh.
Where each item follows the next.
I see.
This predictable order is what defines them.
Okay, so predictable order.
Exactly.
The document starts with vectors,
All right.
which sound kind of familiar.
Mm-hmm.
Are they just a fancy name for arrays?
They're definitely related to arrays,
Okay.
but with a crucial difference.
What's that?
Vectors are dynamically resizable.
Dynamically resizable, meaning?
That can grow or shrink as needed.
Oh, interesting.
While your program's running,
I see.
you get that speed of accessing elements like a regular array,
Right.
but with the flexibility to adjust the size on the fly.
Okay, that's pretty cool.
It is.
How does that work under the hood?
Well, they're cleverly designed, to
Ah.
minimize the performance hit from resizing.
Okay.
Imagine reading data from a huge file where you don't know the size beforehand. With a vector, you can start small and just let it expand automatically as you read in more data.
So it's like,
Yeah,
like having a restaurant that can magically add or remove tables
I like that.
as more guests arrive
Exactly.
without disrupting the diners who are already seated.
You got it.
That's a pretty neat trick.
It is. It is.
The document even includes a code snippet.
Oh, does it?
It shows how you can add elements to a vector.
Okay.
It uses that familiar pushback function.
Right.
Vectorant R for int I, 0i, I5, I++,
I like it.
error day dot pushback.
So you can see it's pretty intuitive.
Yeah, it looks pretty straightforward, that pushback function.
Yeah,
Seems like it'd be super helpful when building up a dynamic array.
definitely.
Are there any
Yeah.
gotchas or limitations to using it?
Well, there are a few things to keep in mind.
Okay.
While vectors are great for adding elements at the end,
Right.
inserting or removing elements from the middle
Yeah.
can be less efficient.
Less efficient.
Yes.
I see.
Remember that restaurant analogy? It's like having to shuffle everyone around
Oh, right.
to accommodate someone in the middle of the seating arrangement.
Makes sense.
Yeah.
Speaking of efficiency,
Yeah.
what about these lists the document mentions?
Lists.
How do they handle data differently?
Lists operate on a completely different principle
Okay.
called a linked list.
Linked list.
Yes.
Oh.
Instead of storing elements contiguously in memory,
Right.
each element in a list points to the next one, forming a chain-like structure.
Interesting.
Think of it like a train,
Okay.
where each car is linked to the one before and after it.
All right, I can visualize that.
This structure makes inserting or removing elements anywhere in the list super fast,
Super fast.
because you just have to change a couple of links.
I see.
It's like adding or removing train cars.
Right, just uncouple and recouple
Exactly.
at the desired point without affecting the rest of the train.
Precisely.
Pretty efficient.
Very efficient.
But this flexibility, I imagine,
Yes.
it comes with a trade-off.
There's always a trade-off.
Right.
Right.
Unlike vectors, where you can instantly access any element using its index, accessing elements in a list requires you to traverse the chain from the beginning.
You got it.
It's like having to walk down that entire train to find a specific passenger.
Exactly.
The document specifically points out that C++ lists don't allow you to use indexing
Right.
like you can with vectors because of this linked list structure.
That's a crucial point.
So fast insertions and deletions.
Yes.
but slower access to individual elements.
That's the trade-off.
It's a classic trade-off in the world of data structures.
Absolutely. And that's why understanding the characteristics of each container is so important. Now, if you're looking for a container that combines elements of both vectors and lists.
Okay, a hybrid.
Sort of.
What would that be?
The document introduces us to deque.
Deque.
Which might sound a bit mysterious.
It does sound a bit mysterious.
A little bit.
Okay, deque. Let's unpack that one.
Let's do it.
It almost sounds like something out of a fantasy novel.
Haha, I can see that.
Deque.
Well, it stands for double-ended queue.
Double-ended queue.
Yes.
Okay.
And it allows efficient insertions and deletions at both ends.
Oh, interesting.
Think of it like a to-do list.
Right.
Where you can add new tasks to the bottom.
Yeah.
Or prioritize urgent ones at the top. And mark them as complete from either end.
So deques are like having two entry and exit points?
Exactly.
Are there any real-world scenarios where this dual functionality would be significantly more efficient?
Oh, absolutely.
Than using a vector or a list?
Yeah, imagine you're building a system to manage customer service requests. New requests are added to the back of the queue, while agents take requests off the front.
Right.
A deque perfectly models this scenario.
Okay, I see.
You wouldn't want to use a list.
Why not?
Because constantly accessing the front would be inefficient.
Right.
And a vector would be less than ideal if you occasionally needed to prioritize urgent requests.
At the front of the queue.
Precisely.
Okay, so each of these sequence containers, vectors, lists, and deques.
Right.
They each have their own strengths and weaknesses.
Exactly.
Depending on how you need to access and manipulate the data.
It all depends on your needs.
This is already making me rethink how I approach data storage in my C++ projects.
That's great to hear.
I've been using arrays for everything.
Well, there's a whole world of containers out there.
That seems like it.
Ready to explore some more.
Yeah, let's move on to those associative containers.
All right.
And see what they can do.
Sounds good.
Okay, those associative containers. They sound like they bring a whole new level of organization to the table.
They do. The
document mentions maps and sets as the key players here.
Right.
What makes them so special?
Well, associative containers are all about efficient retrieval of data based on keys. They provide a way to store information in a structured manner, allowing for quick lookups and modifications.
So it's less about the order of elements like we saw with sequence containers.
It is.
And more about the relationships between pieces of data.
Precisely. Maps, as the name suggests, create a mapping between unique keys and their corresponding values.
Like a key-value pair.
Exactly.
Okay.
Think of a physical dictionary.
Right.
You look up a word, the key, and it directs you to its definition, the value.
Okay, the dictionary analogy makes sense.
It's a good one.
So if I needed to store, say, student names and their grades, a map would be a perfect fit.
Absolutely. The student's name becomes the key.
Right, and their grade is the associated value.
Okay.
And here's where things get really interesting.
Oh.
C++ maps are typically implemented using a powerful data structure.
What's that?
Called a red-black tree.
A red-black tree.
You've heard of those?
I remember encountering them in my computer science classes. Yeah. But they were always shrouded in mystery.
A bit complex,
yeah.
They are a bit complex under the hood. But the key takeaway is that red-black trees are self-balancing binary search trees.
Okay.
This means they automatically reorganize themselves.
Interesting.
To ensure efficient searching, insertion, and deletion of elements.
So no matter how many entries you add or remove,
the
map can always find what you're looking for quickly.
Exactly. Unlike a physical dictionary.
Yeah.
Where adding a new word might require reprinting the whole thing.
Right.
A map powered by a red-black tree can handle new entries without sacrificing speed.
That's impressive.
It is a pretty neat trick. The document even gives some example of how to create a map.
Does it?
Yeah. Oh. And add key value pairs to it.
All right.
std.map, std.string, int my map, 1020 map.
There you go.
So we can see how that works in practice. I'm seeing how this could be incredibly useful.
Yeah.
But what about these sets the document mentions?
Sets.
How do they fit into the picture?
Sets are closely related to maps, but with a key difference.
What's that?
They only store unique keys.
Unique keys.
Think of it like a collection of distinct items.
Okay.
Such as a stamp collection, where each stamp is unique.
I see.
And there are no duplicates.
So sets are all about ensuring uniqueness.
Exactly.
Are they also typically implemented using red-black trees?
They are.
To maintain efficiency?
Yes. That way, checking if an element already exists in the set is a breeze.
Right.
And new elements can be added quickly while preserving order.
We've covered a lot of ground here.
We have.
Vectors, lists, decks, maps, and sets.
It's quite a collection.
It's clear that each container has its own strengths.
Absolutely.
And is optimized for specific tasks.
Right.
But with so many options,
yeah,
how do you decide which one to use in a real-world C++ project?
That's a great question.
It can feel a bit overwhelming.
It can be, especially when you're first starting out.
Yeah.
But the document actually provides a handy summary table.
Who does?
It compares vectors, decks, and lists.
Okay.
And it highlights their strengths and weaknesses in different scenarios.
So the key is to analyze your specific needs.
Absolutely.
And the type of data you're working with.
It all comes down to that.
So no one-size-fits-all solution.
Nope.
It's all about choosing the right tool for the job.
Exactly. Like a good craftsman.
Could you walk us through a few scenarios?
Sure.
And explain how we might make those decisions?
Well, of course.
Okay, great.
Let's say you're building a program to simulate a deck of cards.
Okay, a deck of cards.
You need to be able to shuffle the deck, deal cards from the top,
right,
and add cards back to the bottom.
Okay.
Which container would you choose?
Sounds like I'd need to access and modify elements from both ends efficiently.
Yes.
So a deque seems like the natural choice.
Spot on. Now, let's imagine you're developing a program
to
track inventory for an online store.
All right.
You need to store product IDs and their corresponding stock quantities.
Okay.
Which container comes to mind?
This time, I need to quickly access stock information based on a product ID. A map seems like the perfect fit.
Oh, okay.
Using the product ID as the key,
right,
and the stock quantity as the value.
Exactly. You're getting the hang of it.
I think so.
One last scenario.
All right.
You're building a spell checker.
A spell checker.
And you need to store a large dictionary of correctly spelled words.
Okay.
What would you use?
I need to ensure each word is stored only once.
Yes.
And I need to be able to efficiently check if a given word exists in my dictionary.
Right.
A set seems like the most logical choice.
You nailed it. Sets are ideal when you need to enforce uniqueness and perform fast membership checks.
This is starting to make a lot more sense.
Good, good.
It's like having a specialized toolbox for managing data in C++.
It is.
And now I'm starting to understand which tool to reach for in different situations.
That's the power of understanding these containers.
It really is.
You can write much more efficient and elegant code.
Instead of struggling with clunky arrays.
Yeah.
Or reinventing the wheel.
Exactly.
With my own data structures.
You got it.
Wow, this deep dive
Yeah.
really has been eye-opening.
Glad to hear it.
I feel like I've gone from fumbling around with basic arrays to having this whole arsenal of specialized tools.
That's quite a toolbox.
At my disposal.
It is.
It's incredible.
The C++ STL is a powerful thing.
It really is.
It provides a robust and well-tested foundation for handling data.
Efficiently.
Yes, efficiently.
And elegantly. I mean, it's not about memorizing every single detail of each container.
Right. No, not at all.
It's more about understanding.
It's about the core principles.
Yeah.
The underlying ideas behind them.
So you can make those informed decisions about which one to use.
Absolutely.
In any given situation.
In the real world.
You know, for our listeners out there who might still be relying heavily on basic arrays in their C++ code.
Those who haven't yet discovered the power of the STL.
What's the one key takeaway you'd want them to walk away with today?
I'd say don't be afraid to embrace the power of the C++ STL.
I like it.
These containers offer a level of flexibility, efficiency, and safety.
Absolutely.
That can significantly enhance your code.
It really can.
Take some time to experiment with them, explore their capabilities.
Play around with them.
Exactly.
See what they can do.
And I guarantee you'll find yourself reaching for them more and more often.
I think you're right.
Once you see the benefits.
They really do. Take the pain out of data management
for sure.
in C++.
Absolutely.
And to our listener, we leave you with this thought.
Okay.
Think about your current or next C++ project. Where could you swap out a basic array for a more specialized STL container?
Good question.
Could you use a vector to handle a dynamic list of game objects?
Maybe.
Or perhaps a map to store user preferences efficiently.
So many possibilities.
The possibilities are vast.
They are.
And the benefits to your code can be substantial.
Absolutely.
So until next time.
Happy coding.
See you then.